Class C amplifiers, you know, they will be conducting only for a very, very short duration, and the efficiency is going to be very, very high. And the biasing is also such a way that the conduction angle is very, very less. So the conduction angle is less than 90 degrees, and it is 120 for large signal. So the two conduction angles we have, it is less than 90 or it is 120 for large signal. So if the signal variation is very, very large, the conduction angle is kept at 120. The signal variation level is very, very less. The conduction angle is kept at less than 90 degrees. So remember these two values for conduction angle for class C power amplifier. And when the conduction angle is very, very large, you know, the efficiency will decrease. So for a small input signal, the conduction angle is less, so efficiency is high. For a large input signal, the conduction angle is very, very larger, so the efficiency will naturally tend to decrease. And whenever large currents are going to pass through the transistor, it will cause heating problems. And it is also very difficult to maintain the conduction angle because you are just having one negative power supply minus VEE to maintain the transistor Q point. Otherwise, it will be very, very difficult to maintain the conduction angle in class C power amplifier. So here you can see the application of class C amplifier in different circuit. As I told you, what here you have two circuits. Here I have L1 C2 is one combination and L2 C3 is one combination. So depending on what value of frequency I choose for L1 C2 and L2 C3, only that particular frequency will be available across RL. Okay, so here I can easily extract one particular frequency from the class C power amplifier, and you have this R1 across the base emitter junction. So this R1 is connected to ensure that only when the input crosses a particular value, the transistor starts conducting. Otherwise, the transistor is going to be always in the off state. So the reverse bias will be always present over the transistor. Only when the input signal crosses the negative voltage, it will start conducting. Okay, and you have components L1, C2, and L2, C3. These are also tank circuits. You see L1 and C2 are parallel. This one tank circuit. L2 and C3 are parallel. This one more tank circuit. So depending on what frequencies you are going to tune these two circuits, that particular frequency will be available at the output of your load resistance RL. Okay, so if both are tuned to the same frequency, that frequency will be available across RL. If you want two frequency components, you can have different values for L1, C2, L2, C3, and those two frequencies will be available across the load resistance RL. Okay, so